What happens when one venomous snake bites another venomous snake? At first, the answer seems obvious. A snake sinks its fangs into another snake. Venom enters the body, and the victim dies. But that is not always what happens. In fact, some venomous snakes can survive bites that would be extremely dangerous to other animals. And the reason has nothing to do with them being magically immune. To understand what is happening, we first need to understand one thing. Venom is not just a single poison. It is a complex mixture of proteins, enzymes, and toxins designed to attack very specific systems inside another animal. Some venoms affect the nervous system. They can interrupt the signals that control movement, breathing, and muscle function. Other venoms attack the blood. They can interfere with clotting, damage blood cells, or create internal bleeding. And some venoms begin destroying tissue around the bite. For a mouse, a frog, or another small prey animal, this chemical attack can work very quickly. But a venomous snake may have something that ordinary prey does not. Natural resistance. Over millions of years, some snake species have evolved ways to reduce the damage caused by certain venom toxins. Part of that protection can come from molecules circulating in the blood. These molecules may bind to some venom components before they reach their targets. Imagine the venom toxin as a key trying to reach a lock. If another molecule grabs that key first, the toxin may become much less effective. That sounds like immunity, but it is not. And that difference is extremely important. Resistance means the snake may survive a dose that would seriously harm another animal. Immunity would mean the venom has almost no effect. Most venomous snakes are not completely immune to venom. Enough venom can still cause serious injury, and in some cases, it can kill them. Now things get even more interesting. Snakes sometimes fight members of their own species. They may compete for territory. They may compete for food. And males may compete for access to females. King cobras, for example, can perform dramatic wrestling contests. They raise much of their bodies off the ground and try to push each other down. Not every fight involves biting, but bites can happen. So imagine a species where accidental bites between individuals happen again and again over thousands of generations. Any snake with better resistance to its own species' venom would have an advantage. That does not mean it becomes invincible. It simply means natural selection can favor animals that survive those encounters better. But now imagine something completely different. A king cobra encounters a venomous snake from another species, maybe a viper. The chemistry of the venom can now be very different. A snake that resists the toxins produced by its own species may be much less protected against a completely different toxin mixture. This is one of the most important things to understand about venom. There is no universal snake venom. Different species produce different combinations of toxins. Some are dominated by neurotoxins. Others contain compounds that damage blood or tissue. And even closely related snakes can have different venom compositions. So resistance to one venom does not guarantee resistance to another. Now add another variable, the amount of venom. Snakes do not always inject the same quantity when they bite. A defensive strike can deliver relatively little venom. Some bites may even be dry bites, where almost no venom is injected. But a full envenomation is a completely different situation. A large dose may overwhelm the defenses of an animal that could easily survive a smaller one. Think of the protective molecules in the blood as a limited defense system. If only a small number of toxins enter the body, that system may handle much of the attack. But if a huge amount arrives at once, some toxins may escape those defenses and begin causing damage. This is why two bites from the same species can produce very different outcomes. Where the bite happens can matter too. Venom deposited in one area may spread differently than venom injected somewhere else. And the size of the bitten snake changes the equation again. A large adult cobra and a small young snake are not receiving the same effective dose, even if the exact same amount of venom enters their bodies. The smaller animal has less body mass. That means the venom represents a much larger dose relative to its size. Health also matters. A strong, healthy snake may survive an injury that a sick, stressed, or weakened animal cannot. So when one venomous snake bites another, there are many possible outcomes. Sometimes the bitten snake appears almost unaffected. Sometimes it survives but suffers swelling or tissue damage. Sometimes it becomes seriously ill, and sometimes the bite is fatal. There is no guaranteed result. But snakes are not the only animals that have evolved ways to resist venom. Mongooses are famous for confronting venomous snakes. Their speed helps them avoid strikes. But certain mongooses also have changes in the receptors targeted by some snake toxins. That makes it harder for those toxins to work normally. Some rodents have evolved similar defenses. In areas where venomous snakes are major predators, even a small increase in venom resistance can mean the difference between leaving offspring and becoming prey. And this creates one of the most fascinating processes in evolution: an arms race. The predator evolves a more effective venom. The prey evolves better resistance. The venom changes again. The defense changes again. Generation after generation, each side influences the evolution of the other. This battle has been happening for millions of years, and it helps explain why venom is so diverse today. There is no single toxin, there is no single defense, and there is no magical shield protecting every venomous animal. Instead, each species carries a collection of adaptations shaped by the threats it has faced throughout its evolutionary history. So what really happens when a venomous snake bites another venomous snake? It depends on the species. It depends on the venom. It depends on how much venom was injected. It depends on where the bite happened. It depends on the size and health of the victim. And it depends on how much natural resistance that animal has evolved. Being venomous does not mean being immune. It simply means that some snakes are far better prepared for venom than the animals they normally hunt. And once you understand that, an even stranger question appears. If snakes can resist venom, mongooses can survive dangerous encounters, and some rodents have evolved their own protection. Which animal has the strongest natural resistance to snake venom?